In the last video, we looked at the derivative of some inverse trigonometric functions. And we referenced these formulas here. We looked at how similar they were, arcsine u and arccosine, derivative of those, differ by a negative. Arctangent, arccotangent, again the answer for the derivative, factor -1. The same thing for arcsecant and arccosecant. Now for integrals involving inverse trigonometric functions, we have this one here. If you can write something in this form here, remember here u is a function of x, a is just a constant or a number. So if you can write something in this format, the integral of that expression will equal to arcsine u over a plus the constant. And if you use a U-substitution, your final answer, then you go back and replace the value of whatever you made the substitution. You have a similar formula here for arctangent and arcsecant. So the first one there you see, again, is integral of du over the square root of a squared minus u squared. Anything in that form is arcsine of u over a plus the constant of integration. So let's go to the original problem here. Like I mentioned before, anytime working an integral problem, there's different techniques, as you know already, for integrating. Sometimes you want to simplify the integrand if you can, reduce it. Sometimes you'll have to use long division, especially if you have a rational integrand. Now in this case, another technique that you will use a lot is breaking the integral into two integrals. So for this one here, we can break it down into two integrals by writing this. First integral will be x over the square root 4 minus x squared. So this will be one integral by itself. And we'll have a plus here, another integral, and this will be 2 over the square root 4 minus x squared dx. So if you look at this one here, the first one here, in the denominator we have the square root of 4 minus x squared. So notice, if I look at the 4 minus x squared, the derivative of that is minus 2x. We have an x in the numerator. When that occurs, it's always convenient to use a U-substitution. So for the first integral, I'm going to let u equal to 4 minus x squared. So du, derivative of 4 is 0, derivative of minus x squared is a minus 2x. And that's a dx here. So I need something to replace this x dx. So I want to transform that integral into the variable u, eliminate the x. So let's just say dx. Solve for dx here. So this will be du over minus 2x. And there's several ways to do this. I could just say, well, I need a replacement for x dx. So I can say, okay, well, I got x dx right here. Divide by the -2. And just say, okay, x dx, I can replace it by du over -2. Give you the same thing as this. I can also say, well, it's dx is du over -2x. So if I do that, replace the dx here by du over -2x. Okay, so it should be down here. So see the x then and the x are going to cancel, and I have a factor of -1/2. I'll put that out in front. So now this can be replaced then by the x dx there, and the -1/2 will go in front, can be replaced by du. And then under the denominator, the 4 minus x squared, that's u, and it's the square root. I can just write that as u to the 1/2. Now as far as this one goes here, this is the integral that will lead to the arcsine. The denominator is the square root, and think of the x squared, think of the x here as the u, different from this u that I have over here. It's a separate problem here. So this will be u squared, and then the 4, that would be correspond to the a squared. So this would be, say, if I write it 2 squared like that, u would be the x, and a would be the 2. So according to that formula that we looked at, this comes out to the arcsine. That's going to be u over a. So it's sine of u over a, but in our case u is x here. and a would be the 2. A squared in the formula, in this case, is 2 squared, so a would be 2. And then of course this 2 is constant, so the formula would be 1 over, or du over this 4 minus u squared. The 2 comes along for the right over here, that'll be a 2 there, plus constant of integration. So then we look at this one here then. This is minus 1/2. And let me rewrite this. Take this up to the numerator, make it u to the negative 1/2 du. And then we integrate here. Power rule for integrals here. Add 1 to the minus 1/2 will give me u to the 1/2. And then you divide the coefficient by 1/2. Well, it's negative 1/2 divided by a 1/2 is a negative 1. And then we got the rest of it then. Plus 2. Arcsine x over 2. Plus the constant of integration. And of course, that's pretty much it. The only thing I have to do here is go back to the original variable on the first one. So u is 4 minus x squared. So let's just rewrite this as minus. And then 1/2, I can write that as the square root. U to the 1/2 would be the square root then of 4 minus x squared. And we have a 2, then arcsine of x over 2 plus the constant of integration. So this particular problem then involved breaking down the integrand into 2 integrals using the standard U-substitution in the first one, and then using the formula involving the arcsine. This is your answer right here. Thanks for watching. We'll see you next time.